Alright, big concept with alcohols, Fischer Esterification. So what is an ester? An ester is a compound of the form where we have an R group, carbon double bond in oxygen, a bridging oxygen, and then an R. So it's like we have a ketone adjacent to an ether, and this is what makes esters. Now, Fischer esterification with alcohols can occur three ways. One super easy way to do that we can do in the presence of air is esterification with carboxylic acids. And this is going to be a reaction we drive under acidic conditions, and this is actually a way that a lot of fragrant oils are made. We take an easily produced alcohol, an easily produced carboxylic acid, and we use reactive distillation. So let's talk about the mechanism, then we'll talk about the reactive distillation. What happens is that the oxygen here is going to attack the carbonyl. And through a series of mechanisms, if you're really curious, go look it up in the notes, we're going to end up forming the ester and H2O. And because this is a reversible reaction, what we end up doing is needing to remove the water to really drive this to completion. So if you did something like vinegar and alcohol, you're in water, you're not going to really drive it. What reactive distillation does is that it takes the water that's being produced, and typically our esters and our carboxylic acids are heavier than the water or have a higher boiling point. And so through reactive distillation, we can remove the water and drive it. That said, these are not the only ways to do the esterification. Another option is to start with the acyl chloride. Now the acyl chloride, again, we're going to have an attack here of the oxygen on the alcohol. To give us the HCl. Now, unlike this reaction produced under acidic conditions, we're going to have to run this under basic conditions. And there's a few reasons for this. The big reason is that if we have the base, we'll get rid of the HCl. So this is going to continue to drive the forward reaction by removing the base. Now, another option is we can do it with the carboxylic anhydride. We can do it with acetic anhydride. And this again will produce the desired ester as well as the alcohol. Now, this is also something else we're going to want to run underneath basic conditions. The big reason is that if we add water to acetic anhydride, as the name implies, anhydrides are water-free. If we add the water, we're just going to produce the carboxylic acid. Few things about using the acetic anhydride. One, you're going to want a symmetric acetic anhydride so that you select for the products you want. The second is that you are producing an alcohol with one of these, or you're producing a carboxylic acid, with this reaction. So there are issues of subsequent reactions with this carboxylic acid. Now, this reaction is also reversible, but if we do under basic conditions, we'll remove the carboxylic acid to get the carboxylate ion, which will further drive this reaction to completion. So these are the three ways you can generate an ester with an alcohol. One option, start with the carboxylic acid under acidic conditions, generate the ester, use reactive distillation to remove the water to drive the reaction to completion. Start with the acyl chloride, run under basic conditions to remove the acid that's produced and form the ester. Third option, start with the acetic anhydride, the alcohol, do this under basic conditions, and use the basic conditions to remove the subsequently generated carboxylic acid so you can drive the reaction to completion. And these are the three ways you can do esterification with an alcohol.